Okay, Evgeny, now is your turn, please. We are listening.
Thank you very much. And let me start my report from a little joke. I thank the organizers of this conference for this opportunity to participate and to make this report, in spite of the fact that you tricked me. You have a wrong address on your on your site. So you have written Pokrovsky Street 11, but this building is located on Pokrovsky Street, on Pokrovsky Boulevard 11. Okay, I am Evgeny Gerlitz, and this is a joint work performed by me and my colleagues from the Institute of System Programming of the Russian Academy of Sciences. Denis Kildyshev is here, and also Alexei Horoshilov. Our study, elicitation of functional requirements from the APA documentation for functional testing. And first of all, this slide contains the key terms I will use during my report. I believe that the listeners familiar with the terms written in black, and I will concentrate on the terms, on the colored terms. So let us start with those that are written in blue. Software requirements specification. Software requirements specification is a document which contains all requirements for the software. It is an internal document, and the main readers of this document are software developers and software test engineers. Requirements are carefully written, and they are separated from each other and have unique identifiers, and they contain all conditions under which they became active. And there are even standards that define key properties of qualitative requirements. And these requirements in the software requirement specifications are usually checked against these properties and should meet them. APA documentation is something similar, but from the other hand is different. It is intended for the users of the software, and in spite of the fact that it also describes the behavior of the software, it does it differently. It is supposed that the software provides a number of functions, so-called application programming interface, to other software. Some examples are operating systems or software libraries. These functions are described somehow, but there aren't any requirements with unique identifiers, but some statements about the behavior of these functions. And these statements can be not complete, and they can be ambiguous and not so careful than those requirements in the software requirement specification. And the next term is functional requirements catalog, and it is not an official term, just a list of requirements. Okay, let us go to the terms written in green. The first term, requirements markup. Requirements markup is a process. It is supposed that we have a text, and some statements in this text describe requirements. We select the statements and mark them somehow. For instance, we can use text like HTML text and wrap these statements And this wrapping is meant that this is a requirement. Doing so, we can mark up the whole text. A requirement solicitation process is something bigger than requirements markup process. It usually contains this requirements markup process as a part, but requirement solicitation process can also contain another processes like verification of requirements or supplementation of requirements from different sources. So our task is pretty simple. We have a software, a computer program that provides an application programming interface, and we don't have a software requirement specification, but we have an API documentation. So the task is to extract the requirements from this API documentation and build a catalog of functional requirements. This situation is not rare. I should say that we often face this situation. But the question, you can ask the question, why do we need to extract this intermediate catalog of functional requirements to perform our testing? But we can just use this API documentation and write our tests using this API documentation directly. And my answer, yes, you can, but a thorough testing is hardly possible. And I can give you at least two reasons. The first reason is that it is very hard to count the completeness of our testing, because this API documentation does not contain any separated requirements with unique identifiers. So we are not able to trace our tests to these requirements, and so we are not able to calculate the completeness of our testing. And the second fundamental reason is that it is very hard to provide this high quality of requirements in this API documentation, because we just have statements but not distinct requirements. And this table shows, on the slide shows that the key properties of the requirements are not provided in the API documentation. It is usually the case. And because this kind of documentation is written for the ordinary user, and it is not usually checked. These properties are not usually checked in this documentation. And what are the approaches that we can apply to extract functional requirements from the API documentation? I have found two classes of approaches. The first class of methods are so-called natural language processing methods. These methods use mathematical statistics, machine learning, neural networks to construct a program that will extract functional requirements from the API documentation itself. And nowadays, I believe that nowadays these kind of techniques omit many requirements, and they are not so accurate. In my mind, they can be applied to perform a smoke testing. To perform a thorough testing, we still need to implement a traditional approach, which is on the right on the slide. But what is this traditional approach? A requirements analyst is the key actor in this approach, and he marks up the API documentation manually and does the whole thing himself. But there are two key problems here that we should solve in order that this traditional approach to be effectively applied. The first problem, we need to automate as much as we can labor-intensive and routine tasks. And the second problem, we should provide an appropriate process for the requirements analyst to reach his goal. And his goal is to construct a requirements catalog suited for functional testing. And we also can combine these two approaches, and this can be our future investigation. So let us discuss this traditional approach and how we implement it in our technique. And first of all, about Requality tool. Requality addresses our first problem. We use it to automate labor-intensive and routine tasks while we mark up the documentation, the API documentation. In Requality, we have this requirements catalog in the form of a tree. We can, to build this tree, we just add nodes to other nodes, and only the root node does not have any parent nodes. To assign a text to a node, we just select this node and select the text which describes a requirement, and by right-clicking the mouse, we choose a command that will assign this text to a requirement. But why do we build this requirement catalog in the form of a tree? Let me give you an example. We have here a requirement called errors, and this requirement can say that if there is a problem in a program, then the code of this problem should be assigned to an error variable. And as we hear, this requirement is not accurate. So we can clarify it by adding the child requirements, and these child requirements will correspond to particular errors. So the child requirements clarify this parent requirement, and so this tree describes parent-child relation on the set of requirements, and this parent-child relation leads us to understand the requirements more precisely, and that in turn helps us to construct a more complete set of requirements. Here I start to discuss our requirements solicitation process, and these are the key actors of this process. They are author of the API documentation, technical project manager, software developer, test engineer, and requirements analyst. I will explain the responsibilities of these actors on the next slide. But on this slide, I should say that we don't need 5 persons here to implement our requirement solicitation process. We can just have one person playing these 5 roles, but it is an extreme case. So this, there are our main stages of our requirement solicitation process on the left side of this slide, and the main phases of the testing process are on the right side of this slide. And the first stage of our process is called preparatory stage, and the main actor on this stage is the technical project manager. He assigns priorities to the functions from the API documentation. So as we know, the main part of the API documentation is API itself, a number of functions, a number of function descriptions. So he analyzes these functions and assigns priorities to these functions. And every task performed during this requirement solicitation process will be handled according to these priorities. At the second phase, the main actor is the requirements analyst. He marks up the documentation and builds a requirements catalog. During this phase, he also reveals some bugs in the API documentation and reports them into the backtracking system. And when he reports these bugs, he assigned the priorities to these bugs according to the functions in which these bugs appear. The third phase is the verification phase, in which we verify our requirements catalog built for a function. So the main actors here are the requirements analyst, the developer of the computer program, and the test engineer. I will discuss this phase as long as the next phase on the next slide more carefully. On the right side of the slide is the corresponding testing process. A test engineer chooses the most chooses the function which with the highest priority and writes a test to this function on the first phase. And after the test has been written, start the second phase. And at the second phase, the test engineer performs tracing. He links this test to the requirements which are verified in these tests. This can be done in different ways, but for instance, you can just write identifiers of the requirements from the requirement catalog in front of the test function in comments. And Equality will build requirements coverage report for the test engineer so that he can see which requirements have not been checked.
Evgeny, you have 2 minutes wasting.
10 minutes?
2.
2 minutes, okay. Let's go. Here we have our techniques. These are external techniques that we apply to perform verification and supplementation of our requirements catalog. It is little to discuss here. We just apply them, but I can say that we don't usually apply formal verification techniques because they are too labor intensive to implement. And here I should say that all tasks performed during this process are fixed in 3 systems: task management system and backtracking system. And when we put these tasks into these systems, we assign identifiers to these tasks, and we are able to control when this task, the whole life cycle of these tasks, and doing so allows us to support our prioritization process. So every task is handled according to the priority of the corresponding function, and we also can define verifiable necessary condition to finish our main activities, the requirement solicitation activities for a single function and for the whole requirement solicitation process. Here is the necessary conditions to stop the requirement solicitation process. I will read some lines. Markup of all functions in the API documentation have been completed. All problems in the API documentation should have been fixed. All problems in the requirements catalog should have been fixed, and so on. So this task system and backtracking system allows us to define these conditions to stop our activities. So I am done. This is a so-called association diagram, and I think that every listener has his own understanding of my report, and I will just read some associations, and it will be great if your understanding conforms to this diagram. For instance, API documentation is the source document for the requirement solicitation technique. Requality is the automation tool for requirement solicitation technique. Requirement solicitation technique is the preparation phase for functional testing.
Okay, Evgeny, I have to interrupt you, and maybe somebody will ask you some question.
Okay.
For example,
I'm done.
For me, myself, I have a question. Can you list or refer to some similar works? Is it some similar approaches, publications? What about it?
Sorry, but I didn't understand your question. Could you explain
Where
it in
where
another way?
Where is the references to the literature or publications in this area in your presentation? What about similar works?
You ask about similar approaches that can be applied to solve our task. Am I right?
Yeah. Is that task stated at the very first time in the history?
Probably this slide answers your question. We have two kinds of classes of approaches, and the first class of approaches is so-called natural language processing methods. And
I see. Thank you. We already have seen that. Thanks a lot for your presentation. And now we have to move to the next. Well, Dmitry Vlasov, are you ready?
Yeah, may ask you a question?
Dmitry Vlasov, as far as I can see.
Okay.
Okay.
My question is about number of requirements solicited. Is it possible the situation that if you have some application, if you have some API documentation for this application, and after that you extract too many requirements that it would be impossible to do something with them manually because you extract too small facts about software and
I'm sorry.
It's very, very hard to deal with these facts.
I'm sorry. Our presenter had used all the time for his presentation. So in case you have any additional question, just write to him directly and discuss it. So now we have to move to the next presentation.
Answer your question personally later.
About verification automation of UML diagrams created by students. Well, and we are going to pass our time to the presenter named Dmitry Vlasov. Dmitry Vlasov, are you here? in case Dmitry Vlasov is missing, we can return to Dmitry Koznov and provide him the time to ask the previous presenter. Well, I asked Dmitry Vlasov to let me know when he will be ready. Okay, Dmitry, sorry, you can continue your question. Well, Dmitry?
I have already asked my question.
Well,
I can just repeat it.
so Evgeny, can you answer the question? You have
Okay.
some additional time.
I think I will answer the question.
Well,
When you have a very big catalog of requirements, the general approach is to manage them in some small subsets. On our practice, we are using some sort of formal observation of those requirements. They are checked and so-called commented and formally verified as some set of versioned artifacts. And in this case, by this approach, we are managed those small sets of changes, and at some moments they are not so big. But at the final stage, you will have a great set of requirements managed, verified, and linked together with each other. Of course, if some changed, some related requirements are changed, we also need to check the state of the linked requirements, and we check them. And at the end of this process, we assume that we have some big set of good managed requirements. So I think that's the question.
Okay, thank you. And I'm ask you one more question. Do you use well-known Javadoc format for describing API documentation for Java applications?
According to the approach matched in this article, we assume that we have a documentation in HTML or some translatable to HTML format like doc or something like that. So we can also turn Javadoc to HTML and to manage its path. We are not for now using mechanics to mark up an actual Javadoc.
Okay, thank you very much.
well, no more question, I see. Again, do we have the next presenter named and marked in the program is Dmitry Vlasov? Dmitry Vlasov, are you here? No. The next presentation planned to 20:00 is an approach to automatic software products quality assurance using templates for all levels of the testing pyramid. Dmitry Cherepovsky, are you here? I see.
Yes.
You are here now.
5 minutes.
You are lucky. You have got 12 additional minutes for your presentation.
Thank you. Okay, good afternoon. Today I would like to talk about the problems of testing, automation, and variation of the solutions with the framework in development. The purpose of this work is development of an automated product quality assessment system that solves the main problems in the TDD software development process. In the course, the work the following tasks: were completed. Yeah. Tasks show on slide. Show on slide testing pyramid. The key concept of product quality assessment automation in the testing pyramid, which consists of 3 levels arranged according to the number of test cases and testing objective. User interface, service test, and unit tests. When using the testing pyramid concept, each type of test has its own reports, which are created by analyzing the test coverage. This work takes quite a long time. The ethical designed a tool that generated test reports at all levels of the pyramid and provides then to the project team in a single format. Test-driven development. In TDD, test-driven development, both testers and developers are involved in writing out a test at all levels of the testing pyramid. Since most tests are right and at the initial stage of software development. With this approach, development is carried out cyclically. First, a test is written that covers the desired change. Then the code that will pass the test is written, and at the end, the new code is refactored the appropriate standards. It is when writing out a test and at the refactoring stage that the problems of different understanding of test design by developers and testers. To solve this problem, software development engineer in test specialist reports to using pre-developer the tools framework with already made architecture and the structure of automated tests. Currently, test automation is considered as a project under development, which should easily adapt to several products of any software company. For this, it is necessary to consider all nuances of testing software product. To this end, ISTQB, International Software Testing Quality Board, described the general architecture of the test automation tool. Test general layer, test definition layer, test execution, and test adaptation. Sorry. To solve the problem mentioned, earlier, the most popular test automation tool were analyzed, the results of which are shown on the slide. Among the main disadvantages of the considered tools, the most important one can be identified problem with automatic test reports generation, lack of cross-platform compatibility, and support for a small number language. None of the considered tools provide testing according to the entire test pyramid, which is a significant disadvantage because the tools are designed for use only by the testing teams. On the slide, the table shows the most popular test automation templates, which are used to build the structure of the automated test and test design. The templates are used to write templates for testing automation, which approved in the form is ready-made solution of it for the testing project. The developed test automation tools is based on the following scheme. The developed framework integration, the structure and template necessary for write test into the application source code, which is then filled in by team member at the stage of building the application. Automated tests and performed as a result of which reports on all types of testing are generated based on the received data. The report is deployed to a web server, and the link to view is sent the project team. At the initial stage, a person knowledge and skills in the areas of development, testing, and the product domain. Create a project in the user interface of the tool, view and make changes to standard automated testing templates, storage in the database, or imports predate templates into the project. This slide shows a screenshot of the web interface with the default templates page object for the base web page of the application under tests. After filling in the templates, the framework generated a test structure and create a project to automate testing. The project generator diagram is shows the slide. The generated project, a team of developers and testers writers test according to prepared rules and runs them on the decide part of the development process using test runners. Through the test-based client API for the test-based test plans are automatically analyzed and validated using automated case by name. Later, information about the test coverage is saved in a temporary file. During the test execution, the test completion data is also stored in temporary file, and the report generator generates a report on all the collected information. In the final step, production reports scan the web server and deploy the reports to it. The link to the reports is sent by email to the email address specific in the mailing list via the mail sender. The create reports on automatic test coverage, a test database that contains test IDs or test names and use it. Using the API application program interface provided during the development of the test tools, we get the number of all test cases in the test plan and the number of automated test cases. Based on the data obtained from the test database, we calculate the percentage of the coverage, for example, for the user interface. To display the reports, we use the most popular Allure framework. When create a reports a prepared JSON file with coverage data is used. The data from the file is then simply inserted into the original reports templates. The slide shows the relates of testing a project consisting of the web interface and API with took 10 sprints to develop. The project is implemented in the Python program language. The front end is implemented the JavaScript program language and using the React framework, and the API is implemented via HTTP requests. The table shows the result of comparing test automation with and without the developed tools features. The time was measured in man-hour is in the process of automation testing, the testing of one module on a real project where one sprint is equals to 2 weeks. As you can see, the time spent on planning, writing, and collection reports using the framework has described by almost from 2 to 3 times. Thanks for your attention.
Okay. Some questions, if any? Are there questions? I have one. Again, we see that your presentation does not refer to any similar studies. Well, what can you say about that? This is the first question. And the next one, does the specific of the project influence on the whole approach? For example, there may be projects where the main part is user interface stuff, or maybe projects concerned with calculation tasks only, and so on. How your approach differentiate the subject area of a project, for example? Well,
okay, specific project, yes.
where are the points that can be tuned for the specific projects or cannot be tuned, or this is an absolute universe approach?
Yes, that are
Where is the variety of parts of the approach, depending on the subject area, for example?
because TDD is not new. And there are a lot of existing solution based on TDD.
Sorry, other or not? Can you list some of them? Some similar works. Do you know about them? Or the work is absolutely original?
My work based to templates generation for testing. For example, UMC test generation.
Okay. And how it can be varied according to the nature of the project? For example, my project consists of GUI on 99%.
Okay.
Very,
My
very
project,
very simple task, but very complicated user interface. What will be changed?
the developers create specific template for UI part and back end parts. And based on templates, the test generate.
Okay. Some more questions?
If it's possible, I also like to ask some question. May I?
Yes, yes.
Okay. Generally speaking, when we are speaking about templates and accordingly tests on those templates, the interesting thing is the data. So, are you consider data structure used in the templates? Are you consider of some possible relations between the data passed on your templates to check them on the tests? So something like that.
Templates with use test patterns and templates. It is JSON file and use files for by tests for generate reports. Templates, it is structure code automatically test with patterns.
So you are considering some data interrelations because when we are speaking about the test itself, the key things we need to consider is the data we pass into it. So if we are speaking about the testing, we need to know what we passed and what we could pass into the tests. Is this in the scope of your work or it's out of the scope generally? The data here is related to the variables that you passed.
Data for templates, it is source code tests. Is management by user and of the system. Data is a project or JSON files or codes from structure patterns. And user enter the data for test as input JSON format.
So, as I understood, the data is tend to be out of the scope of your search in this case. Because it's entered by user. Okay, thank you.
Well, more questions? Yes? No? Thank you for your presentation.
Thank you.
And we are waiting for Maxim.
Hello. Hello, do you hear me?
Good day. You can start right now.
Okay. Just a moment. Oh, do you see?
Yes, we do.
Okay. Hello, I'm Maxim Menshikov, and I would like to present you my work on reviewing static analyzer service models. I am a PhD student at St. Petersburg State University and a senior software engineer. I architected many systems for static analysis, virtualization, and containerization, networking, testing, and it was done for various commercial projects. My main project is a QUID, a static analyzer for C, C++, and RC based on model checking and abstract interpretation via symbolic execution of its own intermediate representation. The problem that I would want to discuss is that the static analyzers gradually become useful as components of complex development technologies. Still, most analyzers use...
Maxim, sorry.
Yes?
Can you get closer to the microphone?
Okay, just a moment. Just a moment. Okay. Do you hear me better right now?
Very noisy.
Okay, I will try to talk. Still, most analyzers use to...
Stop. It works when it was before. Eliminate noise, please.
I suppose I can't do it because it's a fan of my laptop. So I can only make microphone louder.
Probably it's your phone.
Yeah. Okay, I'll try to continue that fine. Still, most analyzers are used in a number of...
Stop. We have additional time, so don't worry about. We have to tune.
Just
Alexander, do you hear me?
Yes, I hear you.
Something wrong with sound.
Just a moment. I'll try to improve it.
Stop. Now it's okay. Maxim? No. The reason is on your side, I expect.
Yes, I understand. The problem is the fan of my laptop, most likely. So I'm not sure I can fix it easily.
Well, actually, I can hear you clearly right now.
Right now, it seems acceptable. So.
Okay, sorry, the fan just...
That's fine. You have fixed it.
Okay. The fan behavior improved. Okay, let me continue. Still, most analyzers are used in a limited number of contexts. For example, standalone run, integrated development environment, continuous integration servers, and etc. These scenarios have influence not only on physical users, but also on analyzer internals. The questions which we want to ask are, which implications and effects do service models have? And is it possible to architect a model which is suitable for all of them? I would like to say that our analyzer quit is not out of this equation. When we got direct requests from our customers that want to integrate our analyzer very deeply into their development flows. So that's why we would like to pay attention to this problem. There are many models. I grouped them into 5 groups. First one is a logical presence group. The second is a resource acquisition group. Then the input-output models, change accounting, and history data tracking models. Logical presence models answer the question, where does the static analyzer locate with respect to the end user? There are 3 main models in this group. First one is a local computation group, so that computation is done directly on the developer's workstation. The second group is an isolated computation group. For example, we can talk about continuous integration servers. And the remote computation with resource acquisition. It's the same server which can be used for continuous integration, but which takes data directly from the user. So it's a bit different scenario. On next slides, we'll use the notation like x is less than y is less or equal than that, which means that z and y are equally good, but both are better than x. And it's regardless the semantics of the characteristics which we review. It's important in the next slides. So as for synthetic score, the security is better on all servers. It's an axiom. Another axiom is that the data leaks are less likely on isolated servers. The problem is that developer workstations are not usually secured enough. That's what all security companies say to all their users. On isolated server, we may set up firewall rules which will prevent unexpected data flows. The stable connection is only needed for remote computation model. The network load is significantly better. I mean, it's lower on local computation model. However, isolated model is the worst, but it's more hardware friendly. That means that the gateway which will serve the requests of isolated server will have to create just one network session which will recite through all the data acquisition. As for environment, it's not preserved on isolated server, which might be important for cases when we depend on the system where the code is compiled and executed. And the performance is, of course, better on isolated servers, just because we may install better hardware than we will to developer workstation. The second group is the resource acquisition models. They answer the question, how is the source obtained? The first category is local resources. We just take resources as is from the local machine. The second group is a shared repository. It's what continuous integration servers will do. They will just obtain the source from Git or other repository system. The preprocessing model will preprocess the input to have the data with all dependencies inside. It's just about running preprocessor on the input and making this large output that is produced by preprocessors. The pre-tracing of dependencies is a bit better in that aspect. You just have to run some tool like strace or any other tool to obtain all files which are required by the compiler to compile your file, and you just archive it to make a single package of all involved files. And the virtual network file system approach will just present your file system to the server. So it may obtain the data directly from your computer. The input length is definitely smaller on local model and virtual file system model, and will take care of aggressive caching when using these models. As for shared repository and pre-tracing, we'll just take the whole repository. In most cases, this input length is smaller than it is for preprocessing. As for R&D efforts, virtual file system takes most of them. You'll have to hire some engineer to set up rules to assure that the connection is stable. The pre-tracing will require to use platform-specific tools like strace, so it is also time-consuming and problematic in most cases. Preprocessing and shared repository and local models take literally no efforts. The preparatory work is significantly higher on preprocessing and pre-tracing models than in other models. A stable connection is only needed for virtual file system, and the compiler compatibility is not guaranteed for the case of preprocessing scheme. For example, you can't process all GCC generated preprocessed inputs in Clang. The input-output models answer how is the analyzer controlled by the user. The typical interface is a command line interface. The other approach is a stateless client or server model. For example, REST approach. And then the stateful client server and the streaming models. If we talk about synthetic part of this story, the command line interface model and stateless models take less R&D efforts than other models. The stable connection is only needed for stateful and streaming models. The network load is surprisingly worst on stateless connectivity. The problem is that many small sessions will create permanent load to the gateway involved to data processing. So every packet you send will generate a separate hardware acceleration session on the gateway, or even it won't be actually involved just because you won't pass needed threshold for the acceleration. So in most cases, the gateway will process these packets via the central processing unit, which is definitely slower. Also, as for notifications, stateless model nature doesn't provide it, but of course there may be extensions which add it. As for change accounting, the fixed revision model of course takes most time. The global revision model, which means that we, for example, analyze the kernel every day and just apply developers' diffs to this analysis data, is the most efficient model. And simple incremental updates model won't be as efficient as global revision model in that case in real life development. The analysis part. The incremental scheme requires partial invalidation of analysis data, and global revision needs scheduling of daily updates, temporary storage of artifacts, which of course implies more R&D efforts in the end. And network-wise, there is a higher load on a fixed revision model, although this load is networking hardware friendly. But incremental diffs are always small, so they don't have a great load to the device. Regarding historic data tracking models, there can be no tracking, there can be complete snapshots of data and differential snapshots of data. In all cases, it means that during analysis, meta-runs require some meta-analyzer, which will track if some change is present in earlier revision or it's not present in newer revision, and so on. There should be an extra invalidation of in analysis data, propagation of analysis data difference, which is also about more R&D efforts. And of course, this implies that the more data storage will be used in case of complete snapshots than it will be for differential snapshots. Then we can come to the architecture of model agnostic analyzer. You should pay attention to input abstraction layer, which will take the input from different clients. Then it will pass the data into source preparation and parsing stage, which will take the source from resource acquisition abstraction layer. Then the data is passed to model invalidation based on incremental diffs. And then to analysis stage, which is tightly coupled to streaming communication client. Then the data should be passed to historic data analysis and then to output abstraction layer, which will save the data into the data storage, which should be cleaned up periodically. So the key points are that there should be abstraction layer for the complete execution job subsystem. There should be resource acquisition abstraction layer and a version invalidation subsystem, long-term data storage, and meta-analysis subsystem. This approach has been tested in a real-world analyzer of ours. We used JSON RPC on top of TCP as a base protocol for our analysis server protocol. It's used to control analysis and pace data back and forth. For compiler integration, there is a binary streaming protocol, and our job engine is completely asynchronous, so the jobs can be distributed among cluster nodes. The data can be injected to any running job, and meta-run can be used to analyze different runs. So in practice, we support most of use cases we described in these models. Our observations are that, for example, 10% of input size in case of incremental check makes 20 or up to 40% of execution time, depending on the data being invalidated. The clear advantage is that there is a clear decomposition between the core and the service of the analyzer. And another advantage is that this scheme is not beyond the good architectural patterns, so it doesn't require anything special to be implemented. The disadvantage is the performance penalty. In most cases, it's negligible, especially considering the number of features that this model supports in the end. We also tested networking aspects, for example, in case of polling versus notifications in TCP scenarios. And of course, notification scheme is more efficient, but in general, in both cases, impact to underlying hardware is low, so we can just we can avoid paying attention to this problem. In case of data transfers, for example, we found that SSHFS is slower. It gives us 67 megabits per second in case of Wi-Fi to Wi-Fi link. The pre-processing scheme used significantly more bandwidth, and throughput is around the same as for route TCP. It's just around 80 megabits per second. Suggested use cases for this model are the complete project and inter-project analysis, basic reference research, refactorings, code queries, project import and dependency analysis, debugger support, compiler helpers, static and dynamic analysis cooperation, technical documentation preparation, and all these use cases come from requirements of our customers, which really would like to see that, and also from requirements from authorities like STEC, which would like to, for example, to see that static and dynamic analysis are compared to each other. Eventually, we'll support all of these use cases completely in our project, but most of them are implemented on at least a basic level right now. So, in conclusion, I would like to say that I described the service models which can be used in static analysis. They were compared. I presented the aggregate model, which enables significantly divergent use cases. And in the end, this model was tested in real-world static analyzer, and it demonstrated some advantages and disadvantages. Thank you. Do you have any questions?
Well, thank you. What about questions? No one? Again, my usual question today. Where is the references? So this work is a standalone work, or it is done in some research context that can be described using references?
Okay. We developed the Rusi language with Andrei Nikolaevich Terehov, who is also present here, as far as I know. This language implies a complete development technology, which consists of compilers, analyzers, other tools such as optimization tools, and so on. The analyzer is a part of this project. It's a standalone part, but it integrates deeply within the Rusi framework. So this is the main context. But basically, it's developed completely independently from other parts of the project.
Well, I see. But the project maybe has some history. It has its predecessors and so on. So you have to describe not the content of the project, but is surrounding area. So it might be nice to see some references to similar projects, overview of them, to point out your additional points you have introduced that had been never mentioned before, and so on.
Yes, I agree. Most of the parts that you mentioned are mentioned in the paper itself. Basically, there are different tools such as language servers, which become popular right now. They implement something similar to analysis server protocol, which I mentioned in one of slides, but these language servers are used for different purpose, mostly for syntax highlighting, finding some syntax defects, and so on. So the analysis server protocol is a distinct development which is not seen in other projects. Basically, the model used, the models which are described in this review are used around the world. For example, we can't say that continuous integration servers don't exist. Of course, they do exist. There are tools like SonarQube, which run it on distinct servers. Almost every tool can be run as a standalone tool in a command line interface. So in part, we have these models everywhere. But as far as I know, as I checked other papers, this is the first attempt to categorize these models together in the context of static analysis. And I haven't read about other attempts to make analysis suitable for most of cases which I described. Usually the attention is paid to one of them. For example, to run the analysis every night, for example, to get immediate results, to help the developer. But our use cases are so divergent that they need the model which will have all these traits in one model.
Okay. Maybe somebody wants to ask a question more? No? Thank you very much.
Thank you.
And now we're going to see Damir Gimadinov. Are you here? The team from Huawei.
Yes, right.
Where is the team from Huawei?
Can you hear me?
Oh, okay, Damir. There is some additional sound around here. Let's test.
Just a second, please. I need to configure my workplace.
Yes. Well, say something to test your voice. Damir?
Good afternoon. Can you hear me?
That's nice. So now the last presentation of our section. Damir Gimadinov, an automated system for testing static source code analysis tools. The team from Huawei. You're welcome.
Good afternoon, everybody. I am Gimadinov Damir from Higher School of Economics. My goal today is to present you an automated system for testing static source code analysis tools. It's developed by me and my colleagues as part of our work in Huawei Russian Research Institute. The presentation has the following structure. First, I'm going to pose the problem. Second, I share with you existing solutions for that problem. Third, I present our solution by showing its requirements, class hierarchy, and testing results. And finally, I will finish with conclusion and questions. Let's start with problem statement. Static analysis tools are quite popular today. As a result, there are a lot of them on market, and it could be challengeable to choose the right one. On the other side, process of developing the static analysis tool is difficult and required to check the quality of static analysis tool after every small change. So the problem statement is to develop an automated system, or as we call it, an acceptance testing framework for comparing and testing static analysis tools. Moving on to the next point, I'd like to consider the existing solutions. I consider three solutions. They are Juliet Test Suite, ScanStat, and Seed Test Suite. The Juliet Test Suite was developed by USA National Security Agency and released to the community for analysis, testing, and adoption. It contains three parts for C, C++, C#, and Java languages. Each part consists of some test cases with source code and some additional information, like comments where error in this case happens. Their other two solutions is ScanStat and Seed Test Suite. Both of them are framework for automated running of static analysis tools, but they both limited to represent results of analysis in one report, which our solution is provide an opportunity to extend the possible formats for reporting of results. So it's better to go on the next slide. It will be clear. Let's look at requirements for acceptance testing framework. First two requirements is the independence from target environment, such as operating system and hardware, and from analyzed programming languages. The third and fourth requirements is possibility to check the source code snippets without modification of original code and check other runners as clean code examples. The fifth requirement is to support unlimited number of checkers for coding rules, and sixth and seventh is possibility to compare different static source code analysis tools and possibility to represent results of analysis in different formats, like machine readable, JSON, XML, and HTML. And there are possibility to extend list of reporting formats. Let's have a look at class hierarchy of acceptance testing framework. It mainly consists of four components: tool, driver, test suite, and reporter. Let's take a look at each component, starting with driver. Driver is entry point of framework. It allows to configure tools, static analysis tools, reporter, and test suite. And the configuration of driver takes its place using parameters passed to the framework on the fly. The next component is test suite. The next component is test suite. Test suite is a collection of test cases. It's constructed using provided path to test suite directory. Every test case is presented in two parts. First part is annotation in JSON format, and the second part is source code file. The next component is tool. Tool is a facade representing a static analysis tool runner. It allows to integrate new static analysis tools. Its configuration takes places using parameters passed to the framework on the fly, as for the reporter component. And I'm sorry, like driver component. And the last component is reporter. Reporter accepts framework analysis results and represent it to the one of the three supported formats. First one is text output, just human readable format like in console. The second one is JUnit. JUnit format is useful to integrate with side applications like Jenkins. And the last one is HTML. Here you can see the example of reporter output in HTML format. It contains information about passed or failed test cases category, positive, negative, tool, which someone run on those test cases, and rule. Rule is a defect type, which is developed, which we take from the standard, from the coding standard, for which we create the set of test cases. So let's have a look in testing results. Testing results are computed so acceptance testing framework allow to gather information about passed and failed test cases for static analysis tools, which one run on which one has run. And for these test cases, you can compute metrics such as true positive rate, which is a ratio of number of true positives to sum of true positives plus number of false negatives test cases. In other words, it shows the ratio between all test cases, on which tool have on which tool report an error, to the number of test cases which those contain errors. And other metrics are false positive ratio, precision, and recall. And tested tools, first one is Huawei Python analysis tool, which is developed by me and my colleagues. And the second one is Black 8, and the last one is PyLint. Um, we run those static analysis tools on our test suite. Test suite contains 1,286 test cases, and 61 of them is skipped. That means that static analysis tool doesn't run on them, but we plan to add support for them in future. And I would like to bring your attention to this chart. On this chart, you can see the values of metrics like true positive ratio, false positive ratio, precision, and recall. And as we can see, Huawei Python analysis tool has the best performance along other tools. It happens because of it developed. We're developing that tool especially to satisfy the needs of our test suite. And in conclusion, I would like to say that an automated system for testing static source code analysis tools has been developed. It allows to compare different tools for program analysis, to collect tool statistics on the set of test cases, and to provide additional report formats and analysis tools. Thank you for your interest and attention. If you have any questions, please ask. I'll do my best to answer them.
Thank you. Indeed. Somebody?
I have a question.
Yes. Yes.
So I guess FP stands for false positive ratio, yes?
Yes.
Yeah, and this estimates closed, I guess, yes?
Yeah.
Yeah.
Sorry, we do not see you.
Yes, but from maybe scientific point of view, from research point of view, there are some interesting results in methodics of comparison.
Yes.
So it's not final result, but you
Expected to ask. Yes.
Could you provide some details about this?
How we compute these values? Yeah. So we yeah. So we have run static analysis tools on our test suite, and our framework, acceptance testing framework, report statistics in terms of passed or failed test cases. So, for example, if test case contained the error, it marked as the one that have the error. So the static analysis tool have to report an error on this test case. In that case, it passed. In other case, it failed. And so we have that kind of statistics with passed and failed test cases. And we have like on this slide, we have their number of passed failed test cases for each rule, and we summarize it in total. And for example, we can get the total number of test cases, true positive test cases.
Yes, but this is simple calculations, just an arithmetics. The issue is your results. Next slide, please.
Yeah.
And this one, yes.
Yeah.
It looks surprisingly. Two cases shows similar results, absolutely. Well, and only yours, the blue one, is the best. What is the explanation of this difference? Why two others are similar and why your case is the best? Not in sense of arithmetic comparison, but by contents of the testing and the background, what is happening.
Yeah, I get it. So the reason is SPAT is developed together with test suite, and so it developed in that way that it satisfy every test case from test suite. And for the PyLint and Flag 8, they're
were developed independently, and that's why they are worse than yours. Yes.
Yeah. Yes.
So it seems you're just
it's just one part
for the answer. Yes.
That's one part of the answer. The other part is that SPAT provide is more deep analysis on source code that PyLint and Flag 8, so it can detect the more difficult cases.
Well, this is the interesting point. What is the depth and how it is reached? Why? By what means it goes deeper than others?
Deeper means like it can compute some paths in program which PyLint Flag 8 can't.
May I help to Damir to answer, because I am Gerasimov Alexander and I am leader of the group where Damir works and where this work was done. So there are two simple explanations why this statistics is looking so weird. First one, as Damir said, test suite developed to satisfy a set of rules which SPAT have to detect. And Flag 8 and PyLint supports only subset of these rules. And that's why their statistics looks not so good. It's first explanation. Second explanation that our SPAT tool uses not just a simple syntax checking, but data flow analysis over the Python programs. And that's why some test cases developed to show situation when we don't expect to find the problem. And these situations in test suite called negative test cases, which show the false positive warnings from different tools. And that's why we can calculate true positive ratio, precision, recall, and false positive ratio. I believe I answer your question.
Thank you. Yes, I expected to hear something like that from presentation. Thank you. So, we are done, and we are done precisely in a minute. Yes? Thanks for all. Now you have a break. Thank you. See you after lunch.
Yes, it's time for lunch now.